Okay, so you guys watch 12-1, 12-2? Arithmetic sequences in series. So arithmetic sequences in series are when you are adding or subtracting. Okay, if you're doing arithmetic here, geometric progressions or sequences are going to be given by multiplying. So multiplication or division, and that'll be called a common ratio. So you can go ahead, you can highlight that. Common ratio. So an example of a geometric sequence here would be going 1, 2, 4, 8, 16. We are multiplying each subsequent term by 2. 1 times 2, 2 times 2, 4 times 2, 8 times 2, etc. So if I look at this example here, 2, 8, 32, 128, what is my common ratio? 4. I am multiplying each term by 4. Now, if it wasn't so obvious, what I can do is I can always take my a sub 2 and I can divide that by my a sub 1 because it is given by multiplication. Even if it's division, it would just turn into a fraction, and then you're multiplying by a fraction, which is essentially still dividing. So if you didn't know what it was, you could always go ratio a sub 2 over a sub 1. Okay. Here is a formula, another formula for you guys, lots of formulas for this chapter. This is your general form for a geometric sequence. So when it asks for the nth term of a geometric sequence, it's saying find the formula as given below. Okay, so you have a sub n equals a sub 1 times r to the n minus 1. So you need your a sub 1, you need your ratio. So we'll do that with this example here. We have an a sub 1 of 4, and we want to find our ratio. So that looks to us, if we take a sub 2, negative 12, divided by a sub 1, that's going to give us what? Negative 3. We have a ratio of negative 3. So if we plug that into our formula here, we're going to have a sub n equals 4. I always like to do a times for a space here, just so I remember order of operations. Negative 3 should be in parentheses because it's negative to the n minus 1. So that's our a sub n, and then we want to find a sub 5. I mean, technically, you could just multiply by negative 3 here. This is 108, but we'll use the formula to do it. So we have a sub 5 equals 4 times negative 3 to the 5 minus 1. So negative 3 to the 4th, and then times 4. So negative 3, actually, let's put that in parentheses. Negative 3 to the 4th, and then times 4. So 324 for our a sub 5. Okay, let's look at another example. We want to find a sub 7 and a sub n here. Okay, so those are fractions. So our a sub 1 is 4/5. Now here our ratio is not so obvious. So we're going to want to take a sub 2, which is 2 over 1, and divide that by 4/5. I'm going to write it out that way because now I'm dealing with fractions. Okay, if I wasn't dealing with fractions, I would just write them on top of each other. So here I have 2 over 1 times 5 over 4, which is going to give me 2 times 5, 10, 1 times 4, 4. What's that going to reduce to? 5 over 2. So I have a ratio of 5 over 2. So technically, yes, it's division, but I'm multiplying by a fraction. So it's still a multiplication there. So our ratio is 5 over 2. So our a sub n is going to be our a sub 1, 4/5, times 5 over 2 to the n minus 1. And then we want to find the seventh term. So we'll go a sub 7 is going to be 4/5 times 5 over 2 to the 7 minus 1. This is going to be 5 over 2 to the 6. So the way you're going to want to evaluate that in your calculator, put the fraction in parentheses. So go parentheses 5 divided by 2, and then raise it to the 6. Okay, it gives you that number. Don't worry about that yet. Then go times, and then 4/5 will also go in a parentheses. So parentheses 4 divided by 5. Okay, you get 195.3125. You want that as a fraction. So go math, enter, enter. So 3,125 over 16. Okay, if you wanted to do that by hand, you would have to do 5 to the 6 over 2 to the 6, which 5 to the 6, I don't know off the top of my head. So 15,625 over 2 to the 6, which is 64, and then multiply that by 4/5, and then reduce. You can still do it, it's just more of a pain as opposed to putting your calculator. Okay, so just like we did in the arithmetic sequences, we are now finding the sum. So there's actually two types of sums to a geometric sequence. You have a finite and an infinite. These are actually going to have different formulas for both of these. You can't find the sum of an infinite arithmetic sequence, but you can for geometric. So this is the first formula for us, and this is going to also apply to some financial formulas. You saw some word problems on the quiz, so this would be the one that you're using for some of these. Okay, so this one here, actually kind of a this one you could actually do by hand, but we're going to use the formula here to get through it. All right, so you have use the formula S of n to find the sum of the first 6 terms of the geometric sequence. Okay, so you need a sub 1 and you need r. So here you have a sub 1 is 2. What is our r in this case? 3. Yeah, we're multiplying by 3 each time. Okay, so if we use this formula to find the sum of the first 6 terms, I'm going to have 2, and then 1 minus, we have 3 to the 6 over 1 minus 3. And then just make sure you're using order of operations there. So you've got 3 to the 6th is 729. So you're going to get 2 times 1 minus 729, so negative 728 over negative 2. And then what do you got there? 2 times negative 728 divided by negative 2 gives you 728. Okay, now with this one, you could have written out the first 6 terms, added them together. That would be fine, but I just wanted you to show you how to use the formula, because the next one, well, I'm going to change it so it's a little bit more. Okay, so the next one we're going to use involves fractions. So let's get our a sub 1, and that's going to be 18, and our ratio here. First 2 terms aren't fractions, so you could probably see the ratio pretty easily. What is it? Yeah, negative 1/2. Negative 9 divided by 18. Let's, instead of do the first 5 terms, let's do the first 12 terms. Okay, so if we use the sum formula, you've got sum of 12 equals our a sub 1, 18. Then we'll do 1 minus, and that's going to be r to the n. So our r is negative 1/2 to the 12th, and then over 1 minus our r. Okay, so this double parentheses here, you can make that a bracket, whatever you want to do there. First thing you're going to do is take negative 1/2, raise it to the 12th power. So parentheses, negative 1 divided by 2 to the 12th. That should make it positive because it's even. What is that number? Scientific notation. That E tells you -4 left 4 decimal places. So it's 0.0002. Okay, but you can just keep going. 1 minus this number, so just 1 minus second negative, 1 minus the answer, then you get a better number there. So 0.9998. And that's what goes in this parenthesis here. So 18 times 0.9998. And then we're going to divide that by 1 minus negative 1/2, which is really 1 plus 1/2, which I'm just going to put 1.5 for that. So I'm going to keep this here in the calculator. I'm going to go 18 times my answer, or actually I can just go times 18, and then divided by 1.5. So I get 11.997. I want that as a fraction, if it will give me one. Messy fraction, but it works. 12,285 over 1,024. Yeah. So once you get your final answer, you just go math, and then the first one, it says convert to a fraction is what it's saying, and enter, enter. Let me take a look. Okay, so summation notation. We know that this is geometric because it's got the exponent there. It's got the multiplication. Okay, so here this is saying find the sum of what terms? Yeah, so first 3 terms. I mean, this one really, since it's only 3 terms, you could technically just get them and add them together. That's up to you. Let's use, actually on this one I did just get the first 3 terms. So let's do that. So since it's only 3 terms, let's just go ahead and get them. So just plug 1, 2, and 3 in here. So 18 times 1/3 to the first. That's just 18 times 1/3, which is just 6. 18 times 1/3 squared. That's 1 squared, 3 squared, which gives you 18 times 1/9, which is 2. And then 18 times 1/3 cubed. Let's see here. That is 18 times 1 cubed. 3 cubed is 27. So 18 over 27, what would that reduce to? 2 over 3, yes. And then let's add them together. 6 plus 2 plus 2/3. Let's do it without a calculator. 8 2/3. And if I wanted an improper fraction, 8 times 3 is 24, plus 2, 26 over 3. So we can do it like that. You can check it in your calculator. So looks good to me. Check it as a fraction. 26 over 3. Yeah.
So what they gave you here is already in the form for the sum?
Yep, it is already. It's in that A sub A sub 1 times r to the n minus 1 form. It just doesn't have the n minus 1 in it. We could put it in the sum formula. We should get the same thing. Okay, let's check it. So if we do the sum of our three terms, you've got a sub 1. So a sub 1 was 6. You still have to find 6. You can't take it from here as 18. You still have to find a sub 1. So maybe that's what it is. And then 1, I think it's minus. I don't have this one memorized. 1 minus r to the n. So our ratio we can pull out is 1/3. 1/3 to the third over 1 minus 1/3. So let's check that. So 1/3 to the third is 1. Did you use 18? Yeah, that's probably why. So yeah, then you do 1 minus that, and then 6 times that, divided by 1 minus 1/3, I think it's 2/3. Yeah, get the same thing there. So yeah, if you are using that formula, if it's already given to you in that form, don't just assume that the first term is that one given there. Always plug the 1 in just to check. Right, so if you plug 0 in, then the first term or the 0 term would be 18. It's just coincidental for this one. Okay, so here's an example of a real world type problem where you would actually use this. And there is a question on your quiz like this. So this is a formula. It's similar to the sum formula. So this is future value of an annuity, or with that, it could even be some sort of mutual fund or CD with an interest rate. But usually with a mutual fund, the interest rate varies. So it should just be like an average interest rate over time. Where with an annuity, it's the same all the time. But 12% is unheard of for an annuity. Those are typically like 2%. So just to let you know, that would be more of like a mutual fund. So find the future value of an annuity with payments of $5,000 at the end of each year for 10 years with 12% interest compounded annually. So in here, the little I is R over N. So let's get that first. So our rate is 12%, 0.12. Oh, it's only compounded annually. So it's 0.12. Okay, but sometimes if it's compounded monthly, then you're going to want to change that there. So that should just be a 0.12. So let's plug this stuff in here. So you have your P is your payment. So that's going to be 5,000. Okay, then you have 1 plus our I, which is 0.12, to the NT. So it's compounding 1 time per year for 10 years. So 1 times 10 and minus 1. And then over the 5,000 is multiplied at the end. Move that to the middle. 0.12. So another thing you could do is you could just put a bracket around this whole thing. Just know you have to do all this first, then multiply by 5,000. Okay, so if we do this, you would do 1 plus 0.12, which would be 1.12. Then raise that to the 10th power. And then subtract 1. And then divide by 0.12. Multiply by 5,000. So $87,743.68. Okay, so let's think about that with the interest there. $5,000 for 10 years is $50,000. So that's $37,000 in interest on that. I think there's one that's monthly. Let's just look at it as monthly. Let's say instead of doing 5,000 once a year, you did 500 a month. We'll make it an even one, 500 a month instead. Well, that's a lot for you guys. Let's say 200 a month. 200 a month, good. Let's say, I know it's still a lot. All right, we'll just say, for example, let's say it was 200 a month. Okay, interest is compounding monthly, it's still 12%. So 12% monthly, 10 years. Okay, same formula. Bad A there. Okay. 200. You would have here 1 plus, now this would be 0.12 monthly. So it would be 0.12 over 12 for the I to the n, which would be 12 times t, 10 years, minus 1. Over again, the I changes 0.12 over 12. So then in that one, the I think is 0.1, 0.1. So 0.01, so 1 plus 0.01, 1.01. Raise that to the 12 times 10, which is 120. Then subtract 1. Then divide by 0.01. Then multiply by 200. $46,007.74. But think about that, 200 a month, 2,400 a year for 10 years. You got more, almost more money in there in interest than you do in actual money that you put in. So, and then, I mean, once you get past, if you kept it at that point, once you get past 20 years, definitely more money in interest. The longer it stays in there, the more it's compounding. So you have problems like that on your quiz, which goes just a couple different, I think it was like 20 years and then 40 years, just looking at that. Any questions on using that formula? Okay. The last one is the sum of the terms of an infinite geometric sequence. So this is the last formula here. The other one I didn't highlight because it is given with the quiz questions. You don't have to memorize it, even though the quiz is open book. So how do we know it's infinite? Given to you in summation notation, you have the infinity. One question that you will see that I want to go over on some of the stuff on the homework is, does the sum converge or does it diverge? Okay, so let's look at that first. And you just have to answer that question afterwards. If it converges, then the ratio is a fraction or it's negative. If it diverges, it doesn't converge. It's a whole number. Okay, or if it's a whole number, it could be an improper fraction also, because then it would be greater than 1. So basically the ratio is negative or it's less than 1. Or proper fraction. Proper fraction. Whole number, improper fraction. Okay, so that's what you are looking for. So here's our example. Formula is a sub 1 over 1 minus r. So you have to find a sub 1 first for an infinite series. So find a sub 1. So that's going to be just plugging 1 in, 3/5 to the first, which is just 3/5. And then the r is that term next to the exponent. So in this case, the ratio is the same as the first term. And then we'll use the formula. So that's going to be our sum, a sub 1, 3/5, over 1 minus 3/5. And again, you can put that in your calculator if you like, or you can do it by hand. Totally up to you. 1 minus 3/5 is what, 2/5? So it's 3/5 divided by 2/5, which would then be 3/5 times 5/2. Those 5s would cancel. 3/2. Does the sum converge? No, it diverges. Good. Let's look at a couple more examples. That is an improper fraction, 1.5. Yeah. Yeah, I could just say less than 1 or greater than 1, couldn't I? That's easy. Sorry. Okay, so in this example here, same thing. Find a sub 1. So in this case, it's given to you as 2. What's our ratio? 6. Typically, if the sum doesn't converge, you can't really find the sum because it's infinite, right? It's going to keep going and going and going. It's not going to have a sum. Sum's going to be infinity. So in this one, since you can see that it's just going to keep going and going and going, you don't actually have to find the sum because it doesn't converge. The sum is actually going to be infinity. Now you could actually plug that in the formula and get a number that's not infinity, but that's not the correct answer. Because if you really think about it, it's an infinite series. It's just keep growing, 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 growing. You add all those numbers together, it'll eventually get to infinity. It does, but we couldn't tell when we did it because it was not in this form. It was in summation notation. So that one you had to evaluate it.
Our rate is still less than 1.
The sum was what we were looking at. What?
I'm confusing myself.
The sum, we're looking at the sum. What happens with the sum? Okay. All right, so next example. We'll go through and do this one. So the ratio is a fraction. So we can go through and do this, see what happens here. All right, a sub 1. You're going to plug 1 into the formula. So 3 times 3/10, the 1 minus 1. So that's 0. So that's actually 1. So 3 times 1 gives you 3. So in this case, you can't pull the 3 out. You just always want to check. And then our ratio is 3/10. So your sum of your infinite series is 3 over 1 minus r, 1 minus 3/10. So I'll do this one in the calculator. So let's do 1 minus 3/10 first. So 0.7. So 3 divided by 0.7. And then that as a fraction is greater than 1. 30 over 7. So does the sum converge? No. I don't think I'm going to put any questions on the test that say that unless it is one of the automatic ones that comes with something else. But there are some homework problems with that, just so you know. Let's see here. I think you just have the one practice problem. So go ahead and work on that for a minute because it shouldn't take you that long, and then we will go over it. Okay, so what are we going to get here for our a sub 1? 12, yeah, because we plug 1 minus 1 there, that's 0, so you get 12 there. Our ratio is -3/4. So your sum of your infinite series, 12 over 1 minus -3/4. So let's see what that gives us. That's 1 3/4, so 1.75. So that's going to give us 48 over 7. All right.